geotrig. This is day 2 of lesson 25. So our second question about rates. We got Joe and we got Merrill? Merrill? Myral? Okay.
There's only one, so it's like
Merle. Okay, Merle. Okay. They're washing cars. So Joe can wash 3 cars in 5 hours. Merrill can wash 4 cars in 3 hours. 15 cars need to be washed. If Joe washes cars for 2 hours, then is joined by Merrill. How long will they both have to work together to finish the job of washing 15 cars? I stand corrected. Jake actually showed up to the car washing, and he's the one who could wash 4 cars in 3 hours. So,
no, he actually did. He's not lying about that.
So,
Yeah, he got fired.
Jake and Joe, how long will it take them to work together? How much longer working together to finish the 15 cars? Now, so what we need to do is we need to realize that Jake's car washing abilities and Joe's car washing abilities together will have to complete the jobs, and the jobs are washing 15 cars. Yes?
Yes.
Okay. So, R1 T1 plus R2 T2 will equal the number of jobs. This is the equation that we are going to use, or R, if you use the equation we had on the board yesterday. So we can say that R1s, the ones, will be Joe. 1 equals Joe, 2 equals Jake. Jake's the number 2. So what we can do here is plug in our information. Do we know their rates? Do we know anybody's rate? 3 cars in 5 hours. How do I write that as a rate for Joe? Do I have 3 cars over 5 hours or 5 hours over 3 cars? Because those are both rates.
5 hours over 3 cars.
What am I multiplying that rate by?
By the time.
By time. And I want time to cancel because I want cars left, right?
So you put 3 cars over 5 hours.
Yes, I'm going to put 3 cars on top. 3 cars for 5 hours times T1 plus Jake's rate, R2, is what? 4 cars in
3 hours.
3 hours times his time, yes, will equal 15. That still leaves me with how many variables?
2.
2.
Sometimes the variables are one side and the other.
Well, it's kind of hard to get everything else to the other side because they're 2 different variables with 2 different coefficients. Now, that means I need to write one more equation linking their time together. So the question is, does T1 equal T2? Are their times exactly the same? Essentially, I'm asking, is their time together time? Or does someone have alone time before their together time? Somebody works longer than somebody else.
Joe.
Joe's working longer than who?
Jake.
By how far? So what do I have, where do I have to do to compensate to make them equal?
+2.
Where?
On Joe's side. Jake.
On Jake's side. Because Jake's hours are less than Joe's, so if I took his amount of hours and added the 2, now they're equal. Could I have also done Joe minus 2 hours?
Yeah.
So Joe's time minus 2 hours. Guess what, guys? We now have a system of equations. Here's a first equation. Here's a second equation. I think for this particular system, substitution would be the way to go. Now, do I keep the cars per hour? Is really what's happening here. What's time in? Times in hours, right? Those cancel, 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 cancel. And then you have 15 cars. So do all the labels work out? Yeah, so I'll have some cars times T1, 3 cars T1, or 3/5 T1, 4/3 T2 is equal to 15 cars. So I don't need to put labels anymore. But I do know that it says 3/5 T1 plus 4/3 T2 is equal to 15. Does that make it a little bit easier? Okay. Again, I think substitution might be just a little bit easier on this one. Actually, we can fraction bust, right? Get rid of the fractions if we want. I'll leave it up to you. You guys want to just substitute now? Get rid of the fractions now? What do you want to do? Here's substitute first, okay? And it's a couple people. So, how do I do that? Put T1 in for T1, or T2 plus 2 in for.
Yeah.
Plug this value into T1. 3/5 times T2 plus 2 plus 4/3 T2 equals 15. Probably should have to do what? Distribute. If I distribute 3/5, what do I get? Plus? Yeah, but it's 2 times 3/5. 6/5. Plus 4/3 T2 still equals 15. We haven't changed that. At this point, I got fraction, 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 non-fraction. I don't like fractions. Anyways, I have T2s twice. I could add them together, but it'd be a lot easier to add them together if they had a common denominator. But if I'm going to get a common denominator, why don't I just get rid of the denominator in general? Right? So what number multiplied to both sides will cancel the 5 and the 3?
5 and 3.
Which makes what?
15.
15. So I'm going to multiply both sides by 15. 15 makes 225. What happens when I multiply 15 to the first group? What's 15 divided by 5? Times it by 3. So you get 9t squared. Plus, what's 15 divided by 5 again?
3.
Times it by 6. 18 plus 15 divided by 3 times 4, 20t2. I can gather like terms. 9t2 plus 20t2. 29t2. I'm going to subtract 18 while I'm at it. Equals 207. Is that all right? To find T2, I will divide by 29. Does it come out to a nice number? Calculator out. You know it's more than is it 7?
I think it's just 7.
Does it turn out to be just 7?
I think so.
Well, there's no 7.13. 7.13 what? Hours. Wait, is that 7 hours, 13 minutes?
No.
No, that's not the way it works. Okay. We just found T2's time. Guys, 7 hours, 7.13 hours. What does this represent?
Joe's time.
Who's T2?
Joe.
Jake. Jake's time. So Jake has been working for 7.13 hours. Now, if I wanted to find Joe's time, I can just put that into this one, right?
Yeah.
If I add 2 hours, Joe now actually works what?
Oh, 8 or 9.
Oops. 9.13
Hours.
is Joe's. Is that what it's asking us? How long each one works? Oh, they want to know together time. Is together time? Oh, that must be 16.26 then, right?
Yeah.
No.
No.
How much time do they work together on these cars?
No, it's 14 point.
It's 7.13 hours. Who arrived late to this party? Jake did. When Jake, listen, when Jake showed up, officially together time started.
Yes.
When they finish their jobs, it's done. So Jake's time is together time, therefore they got to wash the cars for 7 hours, 7.13 hours together. So I could have asked what's Joe's time, what's Jake's time, what's together time, how many total hours were put into washing the cars. That's the 16.26, right?
Oh, because all that.
That's how many man hours were put into washing 15 cars. Next problem, Maya could empty 2 bottles in 3 hours. Working with Wilbur, she found that they could empty 4 bottles in 3 hours. What was Wilbur's rate of emptying bottles? Using the same process we did before, but now we got to find the rate instead of jobs or time. So, again, I'm going to modify that equation that we had. How about RMTM? Rate of Maya times her time for Maya plus the rate of Wilbur, time of Wilbur, will equal some number of jobs. Do you guys agree with this? Okay. Do you know any of these things?
Well, we know that Maya could empty 2 bottles in 3 hours.
So that means we have a what?
A rate.
A rate. So that means Maya's rate
So wouldn't it be?
is 2/3, right?
Yeah.
TM plus RW. That's what's in question. What is his rate? So I don't know it for sure.
Isn't it 4?
Then I have TW equals. Oh, wait. Do we have any of this information? How many jobs? The jobs or the bottles emptying? Do we know a TM, RW, TW, or J? Because if I don't know at least 3 of those 4, I can't solve. What do you know, J? What's J? J's back here. But what's J in this problem?
Well, you know, the together.
Ooh, together what?
Together.
Why?
Oh, yeah.
No, we don't know a together rate.
No, we
Ooh,
know
I know a
the
together time and a together
and the bottle.
job.
Yeah.
What is the together time? So wait, you're saying that TM is equal to TW? But that itself equals what?
Job.
No. The time. Together time. 3 hours.
Yeah.
It says it right here. In those 3 hours together, they will finish
4 bottles.
How is
It would be, yeah, it's okay. Let me backtrack on that one. That would be their rate together, overall, yes. But we're not going to use it as a together rate. We're going to use it as a time and a jobs. So now, if I take Maya's time, or rate times the time she's going to work, plus Wilbur's rate times how long he will work for, and we will finish 4 bottles. Yes? Can you solve for RW? And remember, when you solve for RW, it's a rate. When the rate will be bottles per hour. What happens to the 3's in the beginning? Cancel. 2 plus 3 RW equals 4. Or 3 RW equals
2.
And divide both sides by 3. So, Wilbur's rate is 2 bottles per 3 hours. Boom, Wilbur's rate. Now we're going to change things up. Now we're going to be given a problem where you have a group of people working for a given time to complete jobs. So now we have a rate worker time job problem. So remember back to the problems where you used to do the, I lost track. Y equals kx. What are those called again? I'm trying to think. Not ratio. Variation problem. You guys would have solved for k. Remember, we give you x, we give you a y to solve for k, the constant of variation. And that constant of variation never changes. The same thing will happen here with these problems. Your workers on a job site might change. The amount of hours that they work might change. The number of jobs that they work or get done might change. But what won't change is the rate at which they will work.
Why is that? Why wouldn't that?
Now again, just like when we were working together with 2 people, we just assume that their rates won't change when they work together.
Okay.
So basically what it comes down to is if we had to set up a problem with finishing homework problems, I should be able to say that however many problems you guys finish in this class in general on a given day won't change the next day for the given same amount of time.
It was like the making it to the one place someone walked
I don't remember that one at this point right now. But basically, like construction jobs, building a house. You know that the more workers you hire, the faster the house should get done, right? Because each worker is going to contribute a certain amount of work or productivity. That's what we're going to hinge on here, is the fact that once you find the rate, it's always going to be the same. And so, we'll take this out of here. And what you're going to do is you're going to use this equation of RWT equals J. And you're going to be more than likely given how many workers there are, how much time they work for, and how many jobs they complete. And when you do that, you will have to solve for R. And when you solve for R, it'll never change. But then, they're going to change something. They're going to say, oh, they hired 2 more people. How many more jobs can they get done? Or how long will it take to complete the same amount of work with 2 extra people? Or 2 less people? Or more time? Or how long will it take if they give you more time? No, if they give you more jobs? Or take away jobs? These are all things that actually businesses would have to do to make sure that they are running on budget and doing all of those things. So, anytime you talk about workers, jobs, and time, all these different things, you will revert back to the rate worker time equals job equation. So if 5 workers can do 1 job in 8 days, how many workers will it take to do 3 jobs in 7 days? So again, I have rate times worker times time equals jobs. The first thing I should do is fill in the information I know. How many workers? 5. Do I know how long it takes?
Yeah, 8 days.
8 days. How many jobs?
One job.
1 job. Do I know the rate?
No, we don't.
No. But can I solve for it now?
Yeah.
So, R would equal 1 job in
40.
40 worker day, or worker hour days, right? Because 5 is workers, 8 is days, so that'd be worker days. So I could have 1/40th of a job done per worker day. So if you want to put a label on that, that's job worker day. Now the question is, we change up the formula. Still using this whole RWT equals J. We still say, hey, that rate doesn't change. How many workers do I have now? Don't know. I'll call it W. How many days do I get? 7 days. How many jobs? Can you solve for W?
Yeah.
So, would you guys agree that would be 7 over 40 W equals 3?
Yeah.
Multiply it by 40 over 7 to both sides. What's 3 times 40? So 120 over 7 workers. I don't know if that comes out nicely. But how many workers would I need to complete that many jobs in that time frame? Here's 120 divided by 7. 17? Exactly?
Well, we can't have points of a
Well, what's a decimal? 17.14?
Wouldn't it be 18? You need 18 then. You can't have 1 point.
Okay. We're going to leave it at this, okay?
Because then you're losing.
Jake's right. Jake's right.
Yeah.
Here's the thing. In the business world, if you did the calculations and found out that you need 17.1 for worker hour day workers
You have to round up.
to get this job actually completed in your time frame, you would need to have 18th person at some point in your work, or make them work more hours,
Yeah.
something like that.
You have to go up because if you go down, you're losing what.
Ben had 252 gallons of milk. This would feed 42 infants for 12 days. Then 14 more infants were placed in the nursery and 48 more gallons were provided. How long will the milk last now? Who are the workers? Who are the workers? No, it's not Ben. It's infants. Time is days, jobs, drinking milk. So, how many infants are there in the beginning? How much time do they have? 12 days to drink how much milk? Can you solve for R?
Yes.
Okay, R is equal to what?
Well,
42 times 12, and then divide that into 252. What does it end up being? What's 42 times 12? 540?
542. Is it 542? Is that right?
It's 504.
504.
My dyslexia.
So 504, 504. So it ends up being 1/2. You're dividing by 504, right? So the rate is basically 1 infant drinks 2 gallons of milk a day. Or 1 gallon of milk per worker day, infant day. So 1/2. Wait a minute. How many more infants showed up?
14.
So how many are now? 56. Do we know how many days? No, because they're asking us. Equals 48 more gallons pushes us to 300. What's half of 56? And so divide that by 28. Just over 10 days, yes? So homework is on page 181, 2 through 4, 11, 17, and 20. Have a great day.